Hey guys, welcome to your notes for 9.1 and 9.2 quadratic functions and their graphs. So recall from the last unit that a quadratic polynomial is a polynomial of degree 2. Below we're going to list a few examples of quadratic polynomials in terms of x only. So for example, I could write a monomial that's quadratic, like 1/2 x squared. I could write a binomial that's quadratic, like 3x squared plus 1. Or I could even write a trinomial that is a quadratic, like 3x squared plus 2x minus 1. Those are all quadratic because their highest degree is 2. So by taking one of these expressions from above, we can make it a quadratic function. So for example, if I take this middle function, I know I could call it y, which is the same as f of x in function notation, equals 3x squared plus 1. Later on in this unit, we might want to find out when does y equal 2? Well, that will happen when 2 equals 3x squared plus 1. And sometimes we'll subtract that and make it 0 equals 3x squared minus 1. Right? So these are some ways we can take quadratic polynomials and create quadratic functions that we can solve in a quadratic equation. So our quadratic function is a function that can be written in the form ax squared plus bx plus c, where a does not equal 0, and this form is called the standard form of a quadratic function. So here are a few other quadratic functions in standard form. So keep in mind that this quadratic function is simplest when it's just f of x equals x squared. That means a is 1 and b and c are 0. So let's get a visual of what this function looks like. So I can plug in some x values. So remember y equals x squared. So negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is, 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So I can sketch these points. Negative 3 up 9. Negative 2 up 4. Negative 1, 1. 0, 0. 1, 1, 2, 4, and 3, 9. And we'll see that all quadratic functions create this U shape here. And we notice that that U shape is symmetrical across an axis in the middle. This axis is x equals 0 for this one. And the lowest point here is 0, 0. That is our vertex.